Miss Humbert here, and today we're going to be doing Unit 9, Notes 5. So we're going to be talking about multiplying rational expressions. So today we're going to be learning about multiplying rational expressions with monomials and factors, and it's actually going to be really similar to the work you've been doing with multiplying, with just simplifying rational expressions on previous note videos. So let's go ahead and let's take a look at multiplying rational expressions. So here's what you basically want to do. Remember when you're multiplying fractions, you need to multiply the numerator times the numerator and the denominator times the denominator. You do actually multiply out the denominator. So you're going to multiply the numerators and you're going to multiply the denominators, and then you're going to simplify the fraction that remains after that. Okay? So let's go ahead and let's take a look at what that would look like in terms of some problems here. So taking a look at number 1. So what we're going to do is we're going to multiply the top out. So when we multiply out the top out, we're going to multiply the 3 times the 4. Well, 3 times 4 is 12. Now remember, when you're multiplying things of like bases, you need to add the exponents. So a to the third times a to the 6 is going to give us a to the 9. On the bottom, 2 times 2 is 4, and then a to the fourth divided or times a to the third is going to be a to the 7. So we're going to go ahead and we're going to simplify this now. So first we need to figure out, okay, 12 divided by 4. How can I reduce that fraction? Well, as it turns out, 12 is divisible by 4, and that's going to give you 3. Now I'm going to show you a shortcut. If you think way back to Unit 3, when we divide a to the 9th divided by a to the 7th, you can actually just subtract those exponents. Instead of writing out all the a's on the top and on the bottom, which you can still do if you would like, but you can just simply subtract the exponents. So a to the 9th divided by a to the 7th, subtracting those exponents gives you a squared. So that's your simplified monomial, is simply just 3a squared. Now, you also need to find the excluded value, and the excluded value comes in when you actually multiply them together. So 4a to the 7th. So we're going to say that 4a to the 7th cannot be equal to 0. Well, we know that 4 cannot be equal to 0, so all we're concerned about is the fact that a to the 7th cannot be equal to 0. Well, the only way that a to the 7th is going to be equal to 0 is if a is equal to 0. So we get for our excluded value that a cannot be equal to 0 and 3a squared for our final answer. Now let's take a look at this one. So we're going to multiply our coefficients. So 4 times 6 is going to give us 24. B squared times b to the third, you're going to add those exponents and get b to the fifth. On the bottom, 3 times 4 is 12. B to the first times b squared is going to give me b cubed. So first thing I'm going to do is simplify that out. 24 divided by 12 is going to give me 2. Then when I have b to the fifth divided by b to the third, I can subtract those exponents and that'll give me b squared. Now we need to find our excluded value. So 12b to the third cannot be equal to 0. So then we know that just b to the third cannot be equal to 0, and the only way b to the third is going to be equal to 0 is if b is equal to 0. So that is our excluded value. All right, let's take a look at number 3. So for number 3, again, we're going to multiply our coefficients. We're going to take negative 2 times negative 4. That's going to give me a positive 8. Now remember, when there's no exponent on the x, that the exponent is 1. So x to the first times x to the third is going to give us x to the fourth. And then we have 3 times 2, which is 6. And then x to the fourth times x to the seventh is going to give us x to the 11th. So first thing we want to do is try and reduce this fraction. So 8 and 6 are both divisible by 2. So 8 divided by 2 is 4, and 6 divided by 2 is 3. So we have 4/3 for our reduced fraction. Now here I have x to the fourth divided by x to the 11th. So again, I'm going to subtract those exponents. When I do 4 minus 6, I end up getting a negative 7. So you notice how the larger amount of x's is on the bottom, or the x to 11th. So when I subtract them, that's where it's going to end up. So when I subtract it, I get 7. Since my larger of x's is on the bottom, my x to the 7th is going to end up on the bottom. And that's your simplified rational expression. Now we need to find the excluded value. So we know that 6x to the 11th cannot be equal to 0. Well, that's only going to be true if x to the 11th is equal to 0. And that's only going to be true when x is equal to 0. So we're going to say, okay, x cannot be equal to 0. Now let's take a look at number 4. So again, we're going to multiply on top. So we're going to take 3 times negative 2 is negative 6. Y to the first times y squared, add those together and you get y cubed. On the bottom, 6 times 4 is 24. y to the third times y to the third. You're going to add those exponents and get y to the sixth. So now I want to go ahead and reduce this fraction, negative 6 over 24. Well, 6 and 24 are both divisible by 6. So that's going to leave me with a negative 1 on top. 24 divided by 6 is 4. So that fraction is going to reduce to a negative 1 over 4. Now I need to deal with my y's. I have y to the third divided by y to the sixth. Well, when we have those, when I get the difference, I'm going to get 3. Now I notice that the larger amount of y's are on the bottom, so that y to the third needs to be on the bottom for my final answer. So that's my simplified rational expression. To get my excluded value, I'm going to take my multiplied denominator and say, okay, that cannot equal 0. Well, the only way that's going to be equal to 0 is if y to the sixth is equal to 0, and the only way that's going to be equal is if y is not equal to 0. So that's your final answer for number 4. Taking a look at number 5, what we want to do for number 5 is we want to multiply this out. So what I'm going to do is I'm going to take 5 times 16. And when I take 5 times 16, I end up getting 80. And that's going to be divided by 8 times 15. And that's going to give me 120. Well, 80 and 120 are both divisible by 20. Okay, we'll deal with that in a second. So notice how I have all of these letters on top. None of them can be combined because they're all different letters. Same thing on the bottom, except I like to write it out in numerical order because it helps me simplify it a little bit. So 80, I'm dividing each of those by 20. So 80 divided by 20 is going to give me 4. And we can actually divide each of these by 40. So 80 divided by 40 is going to give me 2. Divided by 120 divided by 40 is going to give me 3. So 2/3 is my simplified fraction. So then what I want to do now is I want to simplify out my letters. So here I have a over a squared. Well, a to the first divided by a squared. When you subtract those exponents, you're left with a to the first. Well, a to the first needs to go on the bottom because that's where your large amount of x's is. You can decide if you want to put that 1 in or not. B cubed divided by b to the first, that means b squared is going to be on top when you subtract those exponents. C cubed divided by c squared, subtract out those exponents and you're just left with c on top. So this is your simplified rational expression. Now we need to go ahead and find our excluded value. So we're saying 120 a squared b to the first c squared cannot equal 0. Well, that's only going to be true is if a squared is equal to 0, b is equal to 0, or c squared is equal to 0. So now we're saying that a cannot be 0, b cannot be 0, or c cannot be 0. So that's your final answer for number 5. Let's take a look at number 6. So now we're going to multiply across the top. So I'm going to keep my 5 there. Then I have c cubed times c to the first, add those exponents, that's going to give me c to the fourth. D to the first times d cubed, that's going to give me d to the fourth, and then f squared. Divided by 10 on the bottom, and then c to the fourth times c to the first is c to the fifth, and then d, and then f cubed. So first thing I want to do is reduce that fraction. 5 divided by 10, that can be reduced to 1 over 2. Both 5 and 10 are divisible by 5, and then I'm left with 1 over 2. Then I'm going to have c to the fourth divided by c to the fifth. So I'm going to have, when I subtract 4 and 5, I get 1. My larger amount of c's is on the bottom, so c to the first is going to go on the bottom there. Then I have d to the fourth divided by d to the first. Remember, if there's no exponent, it is a 1. And that's going to give us d to the third, and that's going to go on top because the larger amount of d's is on top. Taking a look, f squared divided by f to the third, that's going to leave us with f to the first power, and that's going to simply be on the bottom because that's where the larger amount of f's are. So now for our excluded value, we're saying 10 c to the fifth d f to the third cannot be equal to 0. So when I look at this, that means that c cannot be 0, d cannot be 0, or f cannot be 0. Hopefully that's something you're getting comfortable with as we move forward through this, okay? All right, let's take a look at some more here. So these are getting a little bit more complicated. So here's what I might suggest doing. Simplify the coefficients early if you can. Well, Miss Humbert, what on earth do you mean by that? Well, I know that 16 can divide 32, right? 32 divided by 16 is just 2. So I'm going to cancel that out to 2. And now I have an even smaller number that I have to deal with, okay? So let's go ahead and let's simplify that. So up top, I canceled out that 16, and all I have left is 3. And then on the bottom, I have 8 times 2, which is going to give me 16. So if you want to, you can try and reduce that fraction as you're multiplying to make it easier on yourself, okay? So now let's multiply out our g's. So we have g squared times g squared on top. That's going to give us g to the 4th. Then we have h to the 3rd times h to the 1st. That's going to give us h to the 4th. Then we have g on the bottom. H squared times h to the 1st is h to the 3rd. And then we also have that j squared on the bottom. So now we want to go through and simplify those. So our fraction is going to stay 3 over 16. Then I have g to the 4th divided by g to the 1st. Subtract those out and we get g to the 3rd. H to the 4th divided by h to the 3rd, and you're just left with h again on top. And that j squared isn't going to be divided by anything, so we're going to leave that on the bottom. Taking a look at number 7, to get our excluded value, we want to take this entire thing and say that it cannot be equal to 0. Well, the only way that's going to be equal to 0 is if g is equal to 0, h is equal to 0, or j is equal to 0. So we're saying that none of those can be equal to 0 for number 7. All right, let's take a look at number 8. So, whoa there, cowboy. Okay, so for number 8, what we want to do is try and simplify this down and advance a little bit. So 7 I can take out of 49, and then I'm just left with 7. Well, 12 and 14 are both divisible by 2, so I'm going to divide this into a 6 and this into a 7. So what I notice is I have a 7 here and a 7 here, and I can cancel that out. Now let's say that just got overly complicated for you. You have no idea how I canceled that out. You can always multiply it out and then simplify it at the end. I'm trying to simplify it a little bit earlier so I can catch it earlier and have smaller numbers to deal with. So let's take a look. So left up top we don't have any numbers. We just have x squared, y, z. On the bottom we have 6, and then I'm going to put that in numerical order. X, y to the 4th, z cubed. So let's go ahead and simplify that. So x squared divided by x. Well, first of all, we're going to have that 6 on the bottom. Well, x squared divided by x to the 1st is just going to leave us with x, and that's going to be on top. And then y to the 1st divided by y to the 4th is going to leave me with y cubed on the bottom. Z divided by z to the 3rd is going to leave me with z squared. So I have x divided by 6y cubed z squared for number 8. For our excluded value, we know that 6x y to the 4th z to the 3rd cannot be equal to 0. Well, that's only going to be true if x is not equal to 0, y is not equal to 0, and z is not equal to 0. So that's your final answer for number 8. Let's take a look at number 9. So first of all, I see a 24 and a 2. So I'm going to go ahead and divide that out right away. So that 24 is going to become a 12. So I have 12 up top, and then I have x squared, y, z cubed. And then I'm going to go ahead and bring that bottom over, and I'm going to have x squared, y cubed, and then z. So let's look. First of all, that 12 is still going to be there. So we're still going to have 12 on top. Then with our x squared, we have x squared over x squared. Well, x squared over x squared is actually just going to cancel out for us, which is super nice. And then we have y to the 1st divided by y cubed. So when I subtract that out, I get 2. And since the larger amount of y's is on the bottom, my answer is going to have y squared on the bottom. Then I have z cubed divided by z to the 1st. Subtract those exponents out, and I get z squared. So that's your final answer for number 9. Now, taking a look at your excluded values, we're saying x squared, y cubed, z cannot equal 0. So that tells us that x cannot equal 0, y cannot equal 0, and z cannot equal 0. And that's your final answer for the excluded values for number 9. Taking a look at number 10, I notice that I have these 3's that I can cancel out. So then the fraction that I'm left with is simply 1 over 6. And then I have a, b squared, c, a cubed, b, c to the 5th. So let's take a look and start by simplifying our a's. So I have a cubed, or a to the 1st over a cubed. Well, 1 divided by 2 is going, or 3 is 2, and the larger amount of a's is on the bottom, so I'm going to have a squared. B squared divided by b to the 1st, that's going to leave me with b up top. C to the 1st divided by c to the 5th, that's going to leave me with c to the 4th. So that's your simplified rational expression. Now for your excluded values, we know that 6a cubed b c to the 5th cannot equal 0. So that means that a cannot equal 0, B cannot equal 0, and C cannot equal 0. And that's our final answer for that one. Taking a look at these ones, so now this is going to be really similar to what you guys did on the previous note sheets. We're just going to cancel off factors that are overlapping. So we can cancel out x minus 3 and x minus 3. And that's going to leave us with x plus 2 over x plus 4. Now, when we go to our excluded values, we need to look at the original bottom. So we need to look at those as if they were multiplied. So x minus 3 times x plus 4 cannot equal 0. So that means that x minus 3 cannot equal 0 and x plus 4 cannot equal 0. So when we add 3 to both sides here, we get that x cannot be 3, subtract 4 here, and we get that x cannot be negative 4. So x cannot be 3 and x cannot be negative 4 for those excluded values. Taking a look at number 12, same thing. Cross off the x minus 6's, and then you have x minus 3 over x plus 4. That's your simplified rational expression there. For the excluded values, we need to take the product of x plus 4 times x minus 6 before it was taken out. Now, we're going to say that each of those cannot be equal to 0. Here, subtract 4 from both sides, so you get that x cannot be negative 4. Here, add 6 to both sides, so you get that x cannot be 6. So we get that x cannot be negative 4 and x cannot be 6 for number 12. All right, last two here. Taking a look at number 13, let's cross off overlapping factors. We can cross off those, and that's it. So then, left over up top, we have x minus 3, x plus 2, and x plus 3. All of that is going to be divided by x minus 2. So if you guys want extra credit, multiply that out for me. Otherwise, I just want to focus on the excluded values for right now. Whoa, hey there, Google Drive. So we have x minus 4 times x minus 2, and we're saying that that cannot be 0. So x minus 4 cannot be 0, and x minus 2 cannot be 0. So that means that x cannot be 4 or 2 when you add those over to the other side. Taking a look at this last one here, we can cancel off the x minus 3's and the x plus 2's. So all that's left is x minus 16 and x minus 12. So to get our simplified rational expression, we actually need to multiply those out using the box method. So we get x and negative 16, x and negative 12. So x times x is x squared, and then we get negative 16x, negative 12x, and negative 16 times negative 12 is 192. So I get x squared minus 16x minus 12x plus 192. So we need to add those middle two terms together. So negative 16 minus 12 is going to give me a negative 28x plus 192. So that's my simplified rational expression, but I do still need to do my excluded values. So on the bottom, I had x minus 3 times x plus 2, and that cannot be equal to 0. So x minus 3 is not equal to 0, and x plus 2 is not equal to 0. So then x cannot be 3 when you add 3 over to the other side, or negative 2. If you need help solving those equations, let me know. So that concludes your note video for today. Go ahead and show me your completed note sheet when you are done. Thanks for listening.